Welcome back. One of the most common doubts I've seen people have when they're working with k-means is what should be the value of k? That is, how many clusters should you have? It's a very important question to answer. So in this video, we'll look at a technique that will help us to choose the right value of clusters for the k-means algorithm. Let's take the customer segmentation example again, which we saw earlier. Here, the bank wants to segment its customers based on their income and the amount of debt. Now, here we can have two clusters, which will separate the customers as you can see in this slide. All the customers with low income are in one cluster, whereas the customers with high income are in the second cluster. We can also have four clusters. One cluster might represent customers with low income and low debt, other clusters where customers can have high income and high debt, and so on. And there can even be 8 clusters as well. Honestly, we can have any number of clusters. Can you guess what would be the maximum number of possible clusters? One thing which we can also do is we can assign each point to a separate cluster, and hence in this case, the number of clusters will be equal to the number of points or observations. So the maximum possible number of clusters will be equal to the number of observations in the dataset. In our customer segmentation example, we can visualize and say that having 4 clusters divides our dataset into pretty much more meaningful clusters. Here we only use two features, right? Which were income and the amount of debt. And hence it was fairly easy for us to visualize and decide the right number of clusters. But what if we have multiple features, which is honestly the case when we are working in the industry? In real life scenarios, we can have hundreds or even thousands of features. Visualizing all those features and then deciding the number of clusters will not be possible. So how can we choose the right value of clusters, the right value of k? One thing that we can do is plot a graph where the x-axis will represent the number of clusters and the y-axis will be some evaluation metric which we'll use to evaluate our clusters. Let's say we'll take inertia for now. You can choose any other evaluation metric like the done index as well based on your problem. Next, what we'll do is we'll start with a small cluster value. Let's say we'll start with 2. So we'll first train the model using 2 clusters, calculate the inertia for that model, and finally plot it here. Now let's say we got an inertia value of around 1000. In the next step, we'll increase the number of clusters to 4 and then train the model again. Again, we calculate the inertia of the model and plot it. Similarly, we can increase the number of clusters in each step, train the model, calculate the inertia value, and plot the results in the graph. As you can see here, these are the results. Finally, we will get a similar graph like this. Now, the question is, how can we use this graph to decide the right number of clusters? If you look at this graph, when we change the cluster value from 2 to 4, the inertia value dropped drastically. Whereas this decrease in the inertia value reduces and eventually becomes constant as we increase the number of clusters further. So the cluster value where this decrease in inertia value becomes constant can be chosen as the right cluster value for our data. Here we can choose any number of clusters between 6 and 10. I can have 7 clusters, 8 clusters, even 9 clusters. You must also look at the computation cost while deciding the number of clusters. If we keep increasing the number of clusters, the computation cost of course will also increase. So if we or our organization does not have high computational resources, which is understandable if it's a startup or a mid-level firm, it is advisable to choose lesser number of clusters. This is how we can decide the right number of clusters in the dataset. In the next video, we'll implement k-means and also plot this graph to decide what should be the right number of clusters or the k value for our dataset. Thank you.